Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Moore's Algebra 2 class. We're continuing here with radicals. Today we're going to investigate radical functions, okay? Remember, a function is any relation where there is only one y value for any given x value. We've seen a lot of different types of functions already. We've seen linear functions. We've worked and seen quadratic functions, absolute value functions, and these are square root functions. Remember that you can evaluate any function. Remember that evaluate just means you plug in a given value for a variable. So you can evaluate any function by simply plugging in x values. Please remember x values or the independent variable. Sometimes the independent variable is g, for example, or w or k or h, okay? But for the most part, our x values are independent variables. We choose values for that, plug it into the function, and solve for the y value or values. Or in other words, the dependent variable. Remember when you go to a movie, if y equals 12x, where x is the number of tickets you buy, your y, your cost depends on how many tickets you buy. You buy 0 tickets, you spend $0. You buy 10 tickets, you spend $120. Okay? So, evaluate f of x equals square root of x plus 2, and g of x equals cubed root of 3x plus 1. Simply plug in and use the skills that we have to simplify these radicals if possible. So, f of 7. What am I replacing the x with, my friends? A 7. So what do I change every single x in this function to? A 7. 7 plus 2 is 9. Square root of 9 is 3. Done. G of negative 3. Wait, negative, Mr. Morrow. Remember, it's an odd root, so I can have a negative here. So I'm going to have, what am I replacing the x with in this particular case? Negative 3. So I have cube root of 3 times negative 3, which is negative 9 plus 1, which is the cube root of negative 8, which is negative 2. Remember, there's a negative there. Pull it out. Cube root of 8 is 2. F of 10. What am I replacing the x with in f of 10? 10. Very good. Thank you, gentlemen. So that's 10 plus 2, which is the square root of 12, which breaks down into 4 times 3, so that's 2 square root of 3. Boom. Done. That's the kind of stuff you're usually going to work with, my friends. We train you with really big, large, crazy numbers so you could understand how to break it down and how to simplify. But usually they're very doable numbers, usually. And usually there's a square root that you could usually pull out, usually. Okay? Does that make sense so far, evaluating? Told you, this is easy, Mickey Mouse. Now, domain, guess what? We've already done it. In fact, we went so far with domain that we know how to find the domain of any function out there. That's how far we've gone already. If you remember, we said that if we have an x in the denominator, we set that x to not equal 0, right, guys? Remember the radical, though. If the root or the index of the radical is even, and it's in the numerator, there's a different rule if it's in the denominator, if you remember. But if the root is, or the index is even, and it's in the numerator, then the radicand must be set greater than or equal to 0. Or in other words, greater than or equal to 0. And solved. Done. Now, for those of you that are thinking, wait a second, what happens in the denominator? Remember that if it's in the denominator, everything is the same except, what do? Except we set it to greater than 0. Why isn't it working now? Why? That wasn't cool. I wanted this pen, yeah. Let's do white. There we go. It'd just be greater than 0 if it was in the denominator. Right? Hello? Are you okay? You're looking at me like I just said something in Chinese. Yeah? You good? Okay. Thank you, my brother. But we're going to deal with them when they're in the numerator. So if you have a radical and it's an even root or an even index in the numerator, set the radicand greater than or equal to 0. Boom! Solve it. This will give you the x values which make the function undefined. Therefore, the domain is every number except those values which make the function undefined. Okay? Everything except those values. And we know how to write domain in both regular inequality form or interval notation. The easy part. If the root of the index is odd, it's all real numbers. Done. Why? Because you can have a negative inside of an odd root. You can have the cube root of negative 8. It's negative 2. You cannot have the square root of negative 8. So if you see an odd, my friends, an odd index or an odd root, don't even sweat it. It doesn't matter if it's in the numerator or denominator, by the way. Cube roots, all real numbers. So again, domain is easy. It's always all real numbers, except if x is in the denominator, set it not equal to 0. If x is in a square root or an even root in the numerator, you set the radicand to greater than or equal to 0. If x is in an even root in the denominator, you set it to greater than 0. Sir? The root can be 5, 7, 9, all real numbers, my brother, as long as it's odd. Any even though, boom, you got to set it to greater than or equal to 0. Does that make sense, my friends? Thank you, gentlemen. So now, Mickey Mouse time. Hey, what's the domain? Oh, wow. It's even, it's square root. Set it to greater than or equal to 0. Literally. Because you can have the square root of 0. So x must be greater than or equal to 5. What's my domain then? That could be the one way of writing it, but you know I like the interval notation way. So how would I do x is greater than or equal to 0, my brother? To 5. How about I learn how to add? Greater than or equal to 5. What would it be? Bracket 5. Positive infinity. Done. If I told you to graph it, 0, 5, bracket to the right. Does that make sense? Okay. I have a cube root of 2x plus 1. Right, exactly. You don't set it to anything. It's just all real numbers. So negative infinity to positive infinity. The graph, you can just put a 0, and it's everything, because it's all real numbers. And if you wanted it in an equality format, it would be x is, let's see. Yeah, less than or equal to 0 and greater than or equal to 0. And boom, you're done. How about for C? The fourth root of 5 minus 2t. It's even. So what must I set the radicand to? You got to set it to greater than or equal to 0. Very good, gentlemen. So I got negative 2t is greater than or equal to negative 5. Divide by negative 2. What do you do when you divide by a negative to an inequality, my friends? You flip it. Very good. So t is greater than 5 halves. What's my interval notation here, gentlemen, please? T is less than 5 halves. Negative infinity all the way to 5 halves. If that's giving you a problem, first graph it. If that gives you a problem, first graph it, guys. Always put your 0. 5 halves is 2.5. It's less than 5 halves. So bracket, go that way. And then that may help you understand, oh yeah, that's right. I'm coming from negative infinity and I'm going all the way to 5 halves. So I've got negative infinity, bracket, 5 halves. Yes, sir.
But since it's even, it does why could it be negative?
It's an even index, son. Even indexes I must set to greater than or equal to 0.
But you can have still a negative infinity.
In this particular case, if I have a negative t, what's negative 2 times negative 2? Positive, so that becomes 5 plus 4, and it's 9. I never said that it's negative infinity to positive infinity. So that for this particular radicand, the values that are going to be greater than or equal to 0 have to be less than or equal to 5 halves. Because once you go over 5 halves, now this does become a negative. Let's say you do 7 halves, just so I can show you. If this is 7 halves, doesn't now this become 5 minus 7, which is the fourth root of negative 2? You can't have that. So I'm not trying to be rude. Don't second guess the facts. Don't second guess the math. Okay, that's the math. That's the reality. You with me? Okay, now, real quick. Graphing functions involving square roots. Remember that the domain of the parent functions of a square root is all real no. I'm sorry. Not. What am I doing? This is wrong. This is from 0. Sorry. 0 to positive infinity. It's greater than or equal to 0. Make a table like we've done before. Choose 3 values, 0, 1, and 2. Yes? Yes. Thank you. Choose your values of x, 0, 1, and 4. Why? Because those are perfect squares. You see the graph right here, 0, 0, 1, 1, 4, 2. This is the way a square root function goes. How do I graph this? Very simple. Choose table values. First find the domain so you can see what values you have to choose. Then make a table of values using the valid x values. Plot the ordered pairs and graph according to the pattern. So the domain in this case, set the radicand to greater than 0. So my domain is x must be greater than or equal to 2. So what am I going to choose? Values of x that are greater than or equal to negative 2. When x is 2, y is 0. When x is 3, y is 1. When x is 6, y is 2. I chose x values that are going to give me perfect squares so I could just graph it. Give me a second real quick, okay? Very simple. You make the table, graph the points, you're done. Or, if you remember, I taught you how to shift and transfer things. I taught you that this h is a shift to the left or right, and it's opposite. Remember that, guys? Remember I taught you that k was a shift up or down? So you could do this. You could go ahead and graph the parent, as you see here, and then what happens here? In this particular example, I have, what am I doing here? What if I wanted to graph, let's say, this one right here, x minus 2. I'm going to the right 2 points. So every point I go 1, 2 to the right. 1, 2 to the right. 1, 2 to the right. And then that's my new graph. Does that make sense? Same exact thing that I did here, you do here with cubic functions. Everything is here for you in your notes, my friends. Everything. Read it. Okay? I'm sorry, I know it's a short class today, but it's stuff that we have seen before, correct? Same thing here. Plug in your values, but for cube roots, remember that you can have negatives. Get out of here. Thank you. Have a wonderful weekend. Homework is valid.